Hi everybody and welcome back to the channel. Today we're going to show you guys how to model the box culvert using robot. So in last week's video I did a more high level video on how to design a precast concrete box culvert, but the modeling, the actual robot modeling, which a lot of maybe possibly students would like to see, we're going to do that here now. So first thing is obviously we open a shell model in robot and we're going to pick our nodes. So we're going to have a look at a 3x3 culvert. I'm going to make a couple of mistakes in this, and in the main it's just to show you how robot can be used very easily to fix mistakes without having to start all over again. Okay, so it's a 3x3 box culvert. I'm popping in the nodes X, Y and Z. So here you can see the 4 nodes. Okay, we use our line beams and we're just picking an RC beam and we're making sure we're picking our concrete. So a drop down menu, C40, C50, whatever you want to pick. And then we pick it that it's going to have it's a design per meter weight, and we're going to have a 300mm thick wall, while 250 will be more common for a 3x3 culvert. Okay, so we're just clicking between our points, and there we have it, we have our box. Okay, so we can use the tools just to get our dimensions, quick check to make sure everything looks okay. And we can turn on our 3D model, see the wall thickness. Yep, so it all looks proportional, looks okay. And with this, we can just click on a beam element down. If we want to, if we had different wall thicknesses, we want to pop it up to 300, you can just go into the properties very quickly and there's a drop down menu. Okay, so what I'm realizing here is that because we have 250 walls and it's 3x3 internal, it should be 3.25 by 3.25 should be the dimensions. So all you need to do is click on the coordinates on the left hand side, and we're literally just changing them really quickly here. Could have stretched it, could have moved it as well, but that's just a quick way of doing it. So now we have 3.25 by 3.25. So when we model a culvert, we should be modeled from the center line of the wall to the center line of the wall. So this is a 3 meter by 3 meter internal culvert. And then if you add on your 250 wall thickness, that's where the 3.25 comes from, okay? So all I'm going to do here then is just pop some nodes. I'm going to move around some nodes from the points into where we would have our chamfer, which would be 125 mil. So the wall thickness is 125 mil, and then the chamfer is 100 mil, so 100 by 100. So 225 would be the distance for the node, and that's where we're going to take the max hogging in the roof of the culvert and also in the outside of the walls. You can add as many nodes as you want, guys, but like we're looking for the results, and to get the values and the results we would need to set up nodes. So for the base then, we're going to break it up into several elements because we want to add supports down here. We want to add spring supports, and the more confined the base, the better the results are going to be. So normally I break the base up into 14 or 15 equal sections, depending on the overall length. For a 3 meter culvert, that's probably okay. So we're going to go with springs, we're going to go with 100 megapascals. And we pop in the values. You can work these out, guys. I would have explained this last week, you know, using Hamley, where you work out the springs, supports, and you pop them in. That's it there. You can see I've broken up into several sections, and we have our spring supports. We have all our nodes done in here now. So now we can add some loads. We're going to go with self-weight first. Okay, and once the section goes red, you know that's been input correctly. We have some fill, obviously, over a culvert. We have some surfacing over a culvert. So we also have our live load. So we just need to change our drop down menu to live. Make sure you go from dead to live, okay? We have our horizontal live loads, so our surcharges on the side walls. So we have it on the left hand side and then we have it on the right hand side. Finally, we just go back to dead and we'll pop in some fill, some horizontal fill. Yes, now we apply the loads. As I was saying, we'll just check that our self-weight is applied properly. It is. Okay. We'll do a quick, I always like to run the model. So I always like to run the model just to double check that it's been accurately built, just with self-weight, okay? You get a feel for it when you have a look at the moment diagram. So we're just going into results here. We're just clicking on MY and we can click on apply. Just for self-weight, we go into our parameters and we just click on text, all and fill. It's the way I like looking at them. You can change this around yourself, but the moment in the roof slab normally kind of coincides with the moment in the base slab, thereabouts, but that looks fairly okay. You can see the roof is sagging and the base is sagging as well on the internal, okay, so which you would expect from it sitting on fill. Okay, so what we can also do here is we can go into the tabulate format for our forces, for our reactions, and we can just check our reactions and we know the overall weight of the culvert, and we can just see here that, yeah, we're getting up around over 80 kilonewtons, and when we back calculate from the actual weight of the culvert, that's what it is. So that's a quick check just to see it's been modelled correctly, the supports are in, they're picking up all the weight of the culvert, and we're designing per metre width. We know the kilonewton total for the weight of a culvert, and then we can just double check. So then I go back and I start putting all the rest of the loads. We'll start obviously with a drop down menu, looking down to fill, and we can pop in for fill. So again, it's in the Z, so it's in the vertical, so we want to go on the Z axis, and we want to go minus because it's a vertical load downwards, okay. Just pick our beam then, and we hit apply. Okay, so we can turn on our buttons down here in the bottom, and we have 12 there. So I'm just saying that the density of soil is 20, and we have 600 mil of soil, so 0.6 by 20 is where 12 comes from. A little bit of surfacing, and over that maybe 200 mil of surfacing at maybe a density of 23. Here we have our live load. We're just going to say we have 25, just popping a UDL live load on it just to get some results here. So we're going to say 25 kilonewtons per square metre of a live load, which would be kind of construction traffic. We have our live load horizontal, which would be the same thing. I'm going to put that on the left hand side. Okay, so we made a little bit of an error here, but we can go into, we can do this in we can just go undo and redo it, but it's going to be a UDL and it should be on the x-axis. Okay, so we just applied it under the wrong we applied it under the live load vertical. Okay, so when we turn on our results to have a look, we can see that it's been applied on the right beam, which is the side wall, but just under the wrong load case. So if we open up the tables, this is a quick way of doing it instead of having to delete load, undo and come back in. But we know here that we've put it into the live load vertical. Okay, so we just need to pick the load, which is, and we just pull the drop down menu and then we pop it onto the side wall. Okay, so it's our 25 is onto the side wall, and then we have the other one on the right hand side. We just change the sign format. Okay, so now we go back into our view and we can see that the load is on the side wall. So we've our left hand side, perfect. Right hand side, no, it should be on beam, it should be on 2, the beam element 2, the right hand side wall. So we're just going back into our tables and we change the 4 to the 2, and we go back to our view and it should have worked perfectly for us. So we have our live load on the left and then we drop down live load on the right. Okay, so that's our UDL live load, and they'll be multiplied by our K factors then when we go into our combinations. We also have our fill on the left hand side, so this will be a triangular load, and it'll be the depth of the culvert. Again, we're going with, I think the culvert is what, 3.25, so it's going to be 3.25 by our 20, which means we have 65 kilograms at the bottom, up to 0 on the top. The horizontal surcharge on the side walls, due to the depth of fill, the 600 mil hasn't been applied, but it should be applied. That's it. That's the 12 there, okay? So this is the surcharge on the right hand wall due to the depth of fill over the box. And now we put in our triangular distribution, our triangular load. So here, as I said, we have our 3.25 depth multiplied by our 20, our density of fill, and that's going to be a triangular load going from 65 up to 0, and it should be the x-axis again. And we just pick our element, click apply. It's in the opposite direction, so again I'll just go in, I'll change that easily in the tables instead of redoing it here. So again, I'll pop in my minus sign and apply it to the wall number 4. And there we go. So 65, that's perfect. So we just need to go back into our tables because we're wrong there with our loads, and we will pick on our load case. We'll go up and we'll see where the 65 is at the top. We'll pop that to 0, and then we'll go back to where it is at the bottom. We'll pop that to 65, and we just press enter and we come out there and everything should be fine. Yep. There it is. Okay, so that's just some typical loads that will be on a culvert. There's obviously more, depending, you're going to have your tractions, your accelerations, different bits and pieces, and then we'll just do one simple load combination here. Loads, we go manual combinations. We'll just do our SLS first. So we're going to just turn on everything, okay? We're going to put self-weight in. We're going to put our fill in. We're going to put our surfacing in. We're going to put our live load in. We're going to put our live load on the walls, on the horizontals, both sides. And we're going to put our fills, both sides. We're going to pop all them in. We're going to just put 0.33, just a typical K value, okay? That will come out depending if you're using PD6694 or whatever other code you're using. You will have to calculate that, okay? This is just a very quick overview. And again, for ULS then we'll pop them in at 1.35, and our 1.5s we're going to change that to 0.5 then as a ULS value for our Ks. Okay, so we can just hit our analyze button and we will solve the model. Everything looks okay, we're not getting any issues. We'll go to our drop down menu, down to results, and then in here we again go to our MY first. Okay, just a quick check here again, reactions to make sure our 25 kPa live load, which is easy enough to check, over 3.25 adds up. All right, does, happy enough. So we're going to just look at the moment, the MY. We'll hit apply, we can hit text all filled again, and we'll just go back and hit normalize to reduce that back to something that looks a bit more like it should. And we have our SLS and ULSs, okay, and that's kind of what you're going to be seeing. And you would design that culvert then based on these values, and you can click on F Z for your shear. So once you have all them results, you can pick your max saggins, max hoggins, and your ultimate shears at D-pass to support and design the culvert based on the wall thickness. Thanks again guys for watching, and don't forget to like and subscribe. Cheers.